we are seeing the reference architecture for enterprises today. So my name is Nicolas Maurice. I am co-founder of PegaSys Orchestrate. I am part of the PegaSys team at Consensus. Before founding PegaSys Orchestrate, I have been working with some in the finance industry building decentralized platforms. And this is basically part of my what I learned in my journey. So maybe a quick word about PegaSys. We mainly do three things. We build infrastructure products. We do some R&D around Eth 2.0 and around a lot around privacy. And third, we also have a small team that is working on standards. So for example, we are working a lot with the Ethereum Enterprise Alliance. About the products that we build, so the ones that you probably know is Hyperledger Besu, formerly named Pantheon. So it's the Ethereum client, Java-based, Apache 2. It's coming with Orion, which is a private transaction manager for Besu, the equivalent of Tessera on Quorum, and EthCC, which is a private key manager. We are selling some extra features around Besu as under the form of license with PegaSys Plus. And since September, we are now also proposing PegaSys Orchestrate, which is an infrastructure system that is living basically on top of your blockchain. And we will be discussing it a bit longer. So those are the products that are today production ready at PegaSys, and we are also working on another product which is more early stage, Teku, so formerly named Artemis, which is our Ethereum 2.0 client. So about Orchestrate, so Orchestrate is basically a middleware that allows you to connect business systems or business applications to blockchain. It provides all the features that you need around transaction management, private key storage, smart contract registry. It is multi-chain, multi-protocol. And we are trying to build trying to do our best in making this software as advanced as possible in terms of, so for example, providing high availability, multi-tenancy, and monitoring. So first, to recap what we mean by transaction management. So we include there so basically managing the life cycle of your transaction from the moment you start generating the transaction, sending the transaction to the blockchain. The transaction will be mined on your blockchain, and then we grab the transaction receipt and we post-process the transaction receipt once the transaction has been mined. So we include there drafting the payload of the transaction, so basically taking your smart contract and creating the bad codes that you need to send to the blockchain to get the transaction executed. We have the gas management. We have everything related to nonce management, the signature of the transaction, sending the transaction to the blockchain, and then when we are post-processing the transaction, so decoding all the logs and events that are generated into your blockchain transaction receipt. So the idea of Orchestrate was to provide a way to abstract all the complexities that is coming when you are trying to build a blockchain platform. And so the first thing that we did was to say, okay, we need this platform, we need Orchestrate to be compatible with any Ethereum blockchain network. So Orchestrate is multi-chain and multi-protocol. When we say multi-chain, is that with a single applicative layer, you can connect to multiple blockchain networks simultaneously. So for example, here you can connect to, for example, an on-premise chain using Hyperledger Besu. You could connect to an Infura node, or you could connect to a Quorum network running on Kaleido. And we are giving you one single endpoint, so you can connect to all these networks simultaneously through one single endpoint. So then around private key storage, so we rely heavily on HashiCorp Vault. So HashiCorp Vault is a technology for secret storage. So basically we have within Orchestrate a specific microservice that we name the transaction signer. This transaction signer is is capable to interact with HashiCorp Vault to sign the transactions. In the design that we have proposed, so the private keys are living in the network isolated zone. So basically, we rely on some asynchronous communication in our backend. So the transaction signer is always pulling information from the outside, and to do that, we rely on Apache Kafka, which is a message broker, a distributed message broker. So basically, when you are requesting the execution of a transaction with Orchestrate, at some point, the payload of your transaction will get in this network isolated zone, so we can sign the transaction in the most secure fashion. So what is interesting there is that you cannot access this area, so the network isolated zone, with an incoming, so basically with traffic that is coming from outside. The traffic is only being pulled from inside, so from the inside. So once you can connect to any blockchain, once you can store your private key securely, now you want to be compatible with any smart contract. So the way what we are providing here is a smart contract registry. So the smart contract registry is basically a storage where you can keep all the artifacts that are produced when you are developing your smart contract. And we are making this so you can integrate it in your development integration. So for example, in your CI/CD process. So for example, here, you would, at some point in your development, push the smart contract to the smart contract registry. And once the smart contract has been registered, the transaction manager will be able to get automatically compatible with the smart contract. So basically saying that any transaction that needs to be generated for the smart contract can be generated, or any receipt that needs to be decoded from the smart contract will be able to be decoded. Another interesting thing that we have been working on is, so right now it's hard to, when you need to trust a smart contract that has been deployed by someone else, the way you have to do it is by basically taking the source code, so for example, use the Solidity source code of the smart contract, compiling this source code, and then comparing the bytecode with the bytecode that is deployed on the chain. It can be quite cumbersome, and when you want to do this in a production fashion and going fast, it's not so easy to do it. So we are working with Mythex, which is the security audit blockchain as a SaaS platform that ContentSys is developing. So when you register your smart contracts in the contract registry, we get this security audit by Mythex. We retrieve some security audit flags that we can keep in the contract registry. And so basically from this point, you can say when you are interacting with a smart contract, okay, I can trust this smart contract because I know that it has been audited by Mythex. So it's compatible with any kind of smart contract, of course, either ERCs or custom smart contracts that you are building for a custom platform. And so now, speaking a bit more, so one of the features which is so must-have for any enterprise blockchain platform is the high availability. So basically, the ability of your system to be available at all times. So basically, if a user connects to your system and requests a transaction, you want to be sure that you will be able to serve this transaction. So for that, we heavily rely on Apache Kafka, which is a distributed message broker, and which allows us to basically go for a multi-availability zone deployment in an active-active fashion. So basically saying that you can have a Kafka cluster with servers in different availability zones, and we deploy Orchestrate also all the microservices of Orchestrate in each availability zone, and by relying on the Kafka multi-partitioning, we can topic multi-partitioning. we can have all these 3 Orchestrate instances active at the same time. So for some other underlying technologies that we are using, so for example, Vault, the high availability setup of Vault is an active-passive one. So you would have one instance of Vault which is active at all time, and the storage underneath with Vault, you can use distributed storage. So for example, you could use Consul, and so that would allow you to get high availability over your private keys as well. For PostgreSQL, that we are using, for example, to persist the smart contracts and the artifacts generated from our smart contracts, you can also have this kind of active passive setup. So for example, if you are on cloud, usually you will use a fully managed PostgreSQL that is basically mirroring this kind of architecture. And then, so something that is getting like very important for enterprises today is how we can control our running costs in a decentralized ecosystem. So basically, taking for example here the example of the Agri Consortium Covantis, there will be around 100 companies in this consortium. The 8 major ones want to have their own stack, so basically getting their own system to connect to the blockchain networks that they will be deploying. But for the majority of those, so for the smaller companies, basically, that cannot afford to have a full stack running. So how can we deal with that is basically by using multi-tenancy. So we are providing one shared stack for all the small companies that are not able to afford to have their complete stack, to pay for their complete stack. And then basically each company will get its own mini Orchestrate. So basically getting its own accesses to blockchain networks, getting its own private keys, getting its own smart contracts, and everything securized basically using authentication control on this single Orchestrate endpoint. So for example, here you could imagine a Besu Orion private network. Each Ethereum symbol here being one Ethereum plus Orion node, and you could have 3 applications. Application 1 accessing the first node, application 2 accessing the second node, and application 3 accessing the third node. And application 1 could not have access to the private information that have been generated, for example, by the node 2, because thanks of this multi-tenancy model. Same, application 1 here will not be able to get transaction signed with a private key that has been created by the application 2, and same for the smart contracts. So that's it for me for this evening. Trying to make your day as short as possible. Thank you for staying, thank you for your time. If you have any questions, I would be very glad to answer. Okay, so thank you very much.
Check, check.